Welcome to all. I am Dr. Shanthi, Associate Professor from the Department of Chemistry, the Standard Fireworks Rajaratnam College for Women, Sivagasi. Now we can see in detail about the mechanism of action of the enzyme chymotrypsin. Enzymes are biological molecules which act as catalysts in metabolic processes. Chymotrypsin is a mammalian digestive enzyme. The name of the enzyme ends with the suffix ase, which is added to the name of the substrate upon which it acts. Chymotrypsin is a serine protease. This reveals that it acts upon the protein serine. The action of enzyme is always very specific, and chymotrypsin is specific in cleaving the peptide bond of the protein molecule. This is helpful in the digestion of the food material which contain protein. The action of enzyme depends upon the way in which the enzyme binds with the substrate to form the enzyme substrate complex, which then dissociates to form the products. The binding of the enzyme with the substrate takes place at the active site, which is a specific part of the enzyme which is having some special charges which is capable of binding with the charged end of the substrate molecule. This structure of the enzyme is given in this slide. Enzyme itself is a protein which is having more number of protein molecules, having more than 245 amino acid units, but the main part is the adjacent placement of 3 amino acids, namely the histidine, aspartame and serine, and these 3 molecules form a catalytic triad which is capable of forming a complex with the substrate. The structure of the catalytic triad is given in this slide. The mechanism of action of the enzyme is depicted by 6 different stages. In the first stage, the polypeptide substrates binds non-covalently with the side chain of the hydrophobic particle. The close proximity of histidine and aspartame makes the proton of serine more acidic, and it is transferred from serine to histidine, and the substrate forms a tetrahedral transition state with the enzyme. Then the H+ is transferred to the C-terminal fragment, which is released by the cleavage of the carbon-nitrogen bond. The N-terminal peptide is bound through acyl linkage to the serine. In the fourth stage, water molecule binds to the enzyme in the place of the departed polypeptide chain. The water molecule transfers its proton to histidine 57 and its OH to the remaining substrate fragment. Again a tetrahedral transition state is formed. The second peptide fragment is released. The acyl bond is cleaved. The proton is transferred from histidine back to serine, and the enzyme returns to its original state. The total action is the splitting of the polypeptide chain to an amino acid and a carboxylic acid fragment. The mechanism of action of the 6 stages is clearly explained in the following slides. In stage 1, the alkoxide ion from serine attaches the carbon of the carbonyl group from the peptide bond, and this leads to the transfer of the electron from the histidine nitrogen to the hydrogen. In the second stage, this hydrogen is combining with the NH of the C terminal, and it is converted to NH2 group. So in the third stage, the C-terminal part of the protein is converted to the amine, and the N-terminal part is converted to a cereal ester. And in fourth stage, the cereal ester is attacked by a water molecule which transfers the OH group, its OH group to the carbonyl carbon and the proton to the histidine molecule, and this leads to the formation of the carboxylic acid in stage 5, and the histidine is again attached with this protein, and the catalytic triad is regenerated. So in stage 6, the OH group from water molecule is attached to the carbonyl end of the N-terminal group, and the hydrogen is attached to the serine part, which is then transferred to histidine, and the catalytic triad is regenerated. So the total action is the cleavage of the long chain protein molecule into a carboxylic acid and an amino compound. So totally the first step is the acylation, and then it is deacylated to form the amino group. Once again, the mechanism is given in these two steps. So this is the total action of the enzyme chymotrypsin. The formation of the enzyme substrate complex is revealed in these two slides. It may be given either by the ball and stick model or the ribbon model. Thank you for visiting.